Compatibility types. The intersection of two objects or classes of objects is the simplest compatibility type. Here I have two different entities, T1 and T2, type 1 and type 2, and their intersection alpha. This indicates that the types are compatible. This is where it gets interesting when you have three types. I think the simplest compatibility type that is a concrete example is the one of a Sol alpha, a Sol mu, and a system. By system I mean like the external world or reality. The spin is the orientation of the type's movement towards a common center R. The spin is the orientation of a type's movement towards the common center R. So it's an arrow that represents the way in which this type is moving towards that common center. This is the movement with, this is the spin with the highest resonance for any spin of three types. Spin tends towards balance, convergence on canceling out. Thus, we would have spin in, spin out, or spin in, spin out are the preferred states for the spin of three types. I want to do something creative. I think this is the most stable structure for the spin of three. Yeah, and it represents the spin by two arrows, or two lines, one for each type. Other spins are it oscillating between these two. Because of the law of cancellation, we would say that they oscillate. They must resonate between these two states. But if I have them all converging on the same point, that looks more to me like three types all pointing to the same point. But then I have to ask myself, what relates those types together? What is the thing that gives this middle point any position whatsoever? And that would have to be the type compatibility represented by lines connecting the compatible types. This should be less stable than this, assuming this can be found. Here I'm using what I call gray diagrams.
1 o'clock.
Two separated dots is the least stable system of two dots. A line connecting two dots is stable. Three dots connected by lines is the most stable, 3. Three dots connected by three lines is the most stable, 3. And it's the first interesting case. And three dots surrounding a point is the first stable, 4. This diagram is the first interesting 4. This is less stable than this. I feel like this inequality holds true. I feel like this inequality holds true. This is less stable than this. And these are all in the order of increasing stability. Dot is more stable than dot dot, is more stable than dot dot dot, is more stable than all the way up to n isolated dots. If we allow foldings, then this holds. So the system tends towards the more stable folding, but it may resonate between the two different forms. We might call this denatured. 4 is when we have what I'm going to call molecules that can fold. 4 points is the first instance of the ability to do folding on the molecule. So the question now for me is, why don't things unfold? Why don't proteins just unfold when conditions are right? Yes, they do fall apart in ugly ways. Let us consider weighted edges. I think that since the resonance is shared, the proper way to write this resonance, the descriptive way, would be to have the resonance of each point at both ends of a line. So if, say, this point has a resonance, that resonance is in both the point that has it and the point it's connected to, shared in some fashion. because resonances appear in more places than once as the most basic definition.
130.
This resonance appears to be modular. It is modular. Here I apply the first instance of recursion on a gray diagram with 3 points, all connected. Continuity, prevent collapse to the inside version, hemisync. So when I'm thinking about compatibility types, I like to think of souls. When 3 souls converge onto the same space, that brings this region into resonance, indicated here by alpha. This looks like chasing a diverging resonance. Well, that was scary to hear. This is a state of discord. This is a state of discord. This looks like resonance, which is movement in a particular direction. 2 converging types and 1 pulling away. Because I consider operators fundamental, I take the limit for any 2 circles, any 2 types, to be those types abutting each other, indicating that the operation is intrinsic to those types. Their relationship to each other is intrinsic. And so that is the singularity I get for those 2 types relating to each other. Here I seem to be indicating that types converge on a resonance. This is another singularity. When alpha cycles between the same set of delta, then we say alpha is resonating. Here I'm using the simplest resonance I know of, and that is 2 objects appearing in different places at the same time. But if I think of it in terms of soul type, then I have a single entity passing a value of that entity to 2 entities. So alpha 1, would be to alpha 1 to alpha 1. Or should it be alpha 2? Because both can be true if something is a resonance. It can be this and it can be alpha 1 passes something that belongs to alpha 1 to an operation alpha 2, delta, and then they pass back some discord to alpha 1, and alpha 1 has to deal with that discord. But it would be better